250,000 tons of Middle East crude on passage to the refineries of northwest Europe. During the 6-week voyage, sediment settles out of the cargo on stringers and tank bottoms to form an unpumpable, waxy sludge that can't be discharged. Historically, this sludge made tank preparation for clean water ballast a long and laborious process, and the eventual desludging at dry dock very expensive. Today, with larger and larger ships, despite high-powered equipment, the traditional water washing on ballast passage leaves more and more to be desired. It's long-winded, only partly effective, and of course, there's always the danger of sea pollution. So the system of tank cleaning with the original medium, crude oil, has been developed, and now is internationally approved and recognized as a major advance in pollution control. The principle is that on suitably fitted ships, part of the discharging crude is bled off through the tank cleaning line to wash the still saturated sediment back into the cargo, where it can be pumped ashore in suspension. All tanks are kept under positive pressure all the time, with inert gas, to ensure the whole operation is completely safe. To avoid unproductive washing over the cargo surface, the revolving heads under the deck automatically cycle between preset vertical angles. Coverage is achieved then in stages by washing separate arcs. Depending on tank construction, normally about 120 degrees for wings and 100 for centers, down to say 70 for the top of the tank, 70 to 40 for the middle, and 40 to 0 for a thorough wash across the bottom. The scouring effect of high-pressure oil jets on freshly revealed sludge is such that only 1.5 cycles are usually necessary for any one arc. Down, up, and down again. So crude oil washing is fast and so efficient that only a puddle of oil is left behind in the area around the pump suction. This residue comes up as a film on the departure ballast, shown here for our purposes only, pressed into the coaming. In practice, the film from each departure ballast tank can be measured in a surface sampler, and the total quantity mustn't exceed the IMCO prescribed ratio. To meet new international regulations, comprehensive manuals are issued with oil washing programs that provide for washing all ballast tanks every voyage and at least 25% of the remainder on a rota system. For example, on a typical ring main ship with a ballast pattern like this, A for arrival, D for departure, 2, 4, and 7, wings and centers, are washed every time, and the rest in a logical sequence to suit operational requirements. On a partial free-flow system, ballasting this way, again it means all ballast tanks, including heavy weather, every voyage, and the others in sensible rotation. Obviously, with full free flow, when this is the ballast pattern, every tank has to be washed. So that's the principle. Now let's look at some operational detail. Crude oil washing inevitably increases the workload in port, so it's essential that all possible preparations are made before arrival. These are laid down in formal checklists issued to all IMCO-approved ships. First of all, isolate the steam heater from the tank cleaning line, so no oil or inflammable vapor can get back to machinery spaces. Then, see that all hydrants are properly blanked, so oil can't drip on the deck. And finally, check that all machine gate valves are shut, so there's no risk of washing into a tank that's not discharging. Meanwhile, in cargo control, set up to recirculate the slop tank and test pressurize the tank cleaning line. When the pump's warmed through, position responsible people on deck to check for leaks. And bleed into the line by opening the 2 valves in the pump room from the discharge main. Open the master valve first, then the heater bypass, gradually, till pressure in the line rises to the design pressure for the particular machines fitted. Now, with pressure in the line, a thorough search must be made round the deck, and any leaks made good and cleaned. Once the system is tested and the pumps shut down again, the first washing machines can be prepared. Equipment varies from ship to ship, but with this familiar type of unit, nozzles under the deck are raised. Collars on the trip sleeves set for the first arc. And portable drives locked in position on the first tanks. A simple lever on some newer machines with built-in drives disengages the whole mechanism, so all setting and resetting can be done in situ. When all the machines are ready, the next thing to check is the IG system, and make sure IG quality in the tanks is correct. It's important too to see that all portable analyzers are in working order. Calibrate oxygen analyzers for 21% normal atmosphere, and test the operation of explosimeters. All the preparatory work, detailed in your manuals, is imperative before arrival if oil washing is to go smoothly at the discharge port, and the prescribed standard of pollution control is to be maintained. And on arrival, it's crucial that qualified personnel, literature, checklists and logs are all available, and the statutory procedures adhered to every time. Once the discharge is underway, slops are discharged early on, and the slop tank refilled with fresh crude to minimize electrostatic generation and to provide a sufficient head to drive washing machines later on when the last tanks approach draining. Now, when the first tanks reach the desired ullage, about a third discharged, wind up the Wesso gauges, open the gate valves, and start the first machines washing the first arcs by reopening the pump room valves and bleeding off the discharge. While crude oil washing is in progress, responsible ship staff must make regular checks for oil leaks, IG quality in the main line, and IG pressure. Crude oil washing, by its nature, must evolve additional cargo vapor in the tanks. As the ullage spaces are already under positive pressure with IG, it's important, especially early in a discharge, to keep a close watch on the pressure. Remember, the PV valve on the riser is set to lift at only 2¼ psi, so it may be necessary at some stage to cut back the IG by adjusting the automatic pressure controller in the pump room. Finally, periodic checks must be made to see that all the washing machines are working properly. They will only work properly as long as the tank cleaning line's maintained at their design pressure. If pressure in the line drops, for instance when there's a low back pressure ashore, it can be restored by partly closing a discharge valve to create an artificial head. When the upper sections of the tanks are clean, usually after 1½ cycles, as each machine comes down to its lower limit, reprogram for 70 and 40. Then, when the tanks are about 2/3 discharged, start washing the second arc. When the middle section's washed, reset again and wait till there's only about 1 meter of cargo left before starting on the bottom arc, between 40 and 0. Obviously, the worst sediment is on the tank bottoms, so it's essential that this wash is really thorough. And always ensure that the last pass of the jets is across a dry tank bottom. As soon as the first tanks are finished, shut down the machines, set controls back for the first arc, and move portable units onto the next scheduled tanks. As ullage in these tanks reaches the first level, open up the machine valves and the three-stage sequence begins all over again. 2 of these moves may be needed to wash the specified number of tanks, depending on the class of ship and the number of drive units fitted. But on approved ships, it will never be more than 2. Either way, the procedure for each batch of tanks will be the same. Partway through the discharge, on most ships, wing tanks will be simultaneously ballasting. But, as we've seen, ullage spaces are under positive pressure with mixed inert gas and cargo vapor. So ballast flow must be carefully regulated to a rate that ensures no imbalance of pressure either vents cargo vapor to the atmosphere or draws in fresh air. Early in the program, we saw the slop tank was discharged and refilled with fresh crude. Now, as the last tanks approach draining and there's insufficient head to power washing machines, discharge is stopped, suction taken directly from the slop tank, and the oil in there used for the final bottom wash. At the same time, the pump drives eductors, which recirculate the crude to maintain enough head in the slop tank. When the final bottom wash is complete, washing machines are shut down, and the eductors strip out the last drainings. After about 15 minutes, when no more oil can be removed, eductors are shut down, tank cleaning lines drained, and the slop tank discharged. But of course, there's still a lot of oil left in the big discharge lines on deck, so they're drained back to the slop tank. And using the stripping pump on a specially fitted small bore line, those drainings are discharged too. Now the only crude left on board is a few tons in the small line between the pump room and the outboard side of the manifold valves. The procedure we've seen applies to a routine wash at one port, but the system can easily be adapted to other situations. When cargo is discharged at more than one port, for instance, time can be saved by oil washing at sea between ports, either washing exposed sections of part-filled tanks, or, after a quick part discharge, by transferring cargo and washing selected tanks as levels go down. Washing this way between ports is standard procedure, but it is not permissible to retain cargo for any washing on the ballast passage. All crude oil washing must be complete before leaving the last discharge port. Tank washing with crude oil means approved ships now make their ballast passage virtually oil-free. One big operational advantage for this is the huge reduction in time spent water washing at sea. Only an hour or two's rinse for clean ballast or tank inspection, and 1 to 2 days in preparation for dry dock are now needed. Of course, all other operations like purging, gas freeing for entry and subsequent re-inerting must all be as strictly observed as ever. Tank washing with crude oil is quite a new technique. In a few years, it may be the only way. It means cleaner ships, more time for maintenance, less retained slops, more cargo turned out, and most important, less risk of sea pollution. It means learning a few new drills, but detailed manuals and guidelines are available. Make sure you learn them. Make sure you get to know the new procedure now.